Good afternoon, students. Checking. Can you hear? Good. You can see the screen?
Okay.
Just make sure.
Yes, sir.
All right, beautiful. So we are back. Guys. So been basically just been scratching the surface the last couple of days because I had some issues starting out. But we are back just in time to go fully into our exam prep. Starting today. I'm low.
More like echo or so, sir.
Like an echo?
Yes, sir.
Don't know. Yeah, I didn't think about it. Everybody hearing an echo? Everybody hearing the same echo? I don't know if it's because I'm out of place. But I'm actually in the classroom. I don't know why. Because I'm using everything the same as I normally do. Hold on, I'm turning off one of these fans. Hold on. All right, can you hear me any better? Hello?
Still the same, sir. Then it's still the same.
There's an echo, but you can hear me.
Yes, sir.
All right, just have to work with it, guys. All right, because I can't do that. I think maybe there's an echo in the classroom. I don't know why there's an echo in the classroom today, but yeah, I don't know. Because I'm using everything that I normally use. So, but let us do this still. Let us do this. Right. So I was basically just saying that, we're going to be going into full exam preparation mode now, just declaring that. And it's going to involve us doing 4 mock exams every week. All right. So, we're starting on Saturday, just that we're going to break for the week of champs. But then once champs is over, I'll come back. We're going to be all guns blazing, a lot of work. All right. So that we can clear up everything and get ourselves fully prepared to crush the exam when it comes on May 9th and then again on June 6th. That's the whole aim. Crush that exam. All right. So we're going to prepare ourselves fully, leave no stones unturned. All right. So that's why it's going to be a lot of work, because we want to make the exam easy. We want to work hard to make the exam easy. All right. So we're done on this paper in the last class, and we had actually gotten to this question, number 7. So I have 7, 8, 9, and 10. Just 4 questions. So I prefer to do those 4 questions in this one session. All right. So this is the pattern question, as you can see on the screen. And it's very, very typical to what you will normally see on a pattern question. It says, a sequence of figures is made from lines of unit length and dots. The lines form a series of octagons and squares. All right, so you have these squares inside here. These are the squares here and here. And clearly, these are your octagons. So that's an octagon. This is another one right here. It's another one right there. Right? So the squares are in the corner right here. So these are some squares again. All right, so what we're gonna need to do as usual is to look and see how the pattern is created, or is it created. All right, so if we look at it, they give us the first 3 figures, as I normally do. And it says figure 3 of the sequence is shown by itself. So they've given us figure 3. And in this example, they wanted us to add lines of unit length and dots to correctly represent figure 4. So basically, they want us to extend this figure 3 to form figure 4. All right. So if I zoom up, you can see that what does that mean to go from shape to shape? Is that you're basically adding one of the octagons. You're adding this octagon. adding it to here. So this octagon is added here. And then when the octagon is added, let me just move it across to show it. When this octagon is added there, then they also add this square, this one down here as well, to kind of join the octagons, right? So these were added to that. So basically, all of this is what you basically keep adding. This thing is what you keep adding. So we basically need to add back this same shape to here. All right, just that I'm going to trace out this octagon a little bit more clean and then just add it. Or you can actually trace out this shape right here and then add it. All right, so we can do it from this one. So because I have the device, I can do that. I can trace it out and then just copy it across. But this is what you're adding. You're adding an octagon. Remember to add the dots as well, right? The black dots. So this is what we're adding. That octagon, and then we're completing a square. Right here. And then is there anything for the dots? Let's see. I think they mentioned the dots as well, right? The dots, right? Number of dots. So we're also adding the dots. These dots are added here, here, here. All these dots get added to the existing shape. This one will be on it already. All right, so this is a shape that we basically adding. So I can take this now, slide it across, and put it in the position. And that is what is added to the original shape. Something like that. All right, so that becomes your new shape. Figure 4. That's it. Figure 4. Better go to that. Nice and easy.
Yes, sir.
All right. Go to 4. Let's continue. We're gonna go to the device kind of slow today. All right, so we're going to the table now. We're going to look at the pattern in the table. As usual, the method I prefer is to fill out this formula line first, and then use this formula line to fill this out. All right, that's the approach that I like to use. Let's see if we can establish a formula for these. All right, it says the number of dots D and the number of unit lines that form the perimeter P of each P form a pattern. So the values of D and P for the first 3 figures are written in the table below. Study the pattern of numbers in each row of the table and then want us to complete these rows down here. All right, the tablet kind of moving slow, guys. Complete those. There's some stuff happening in the background. All right. So what we want to do is see if we can pick up the formula to fill out down here. And most times, as I said, what it is that you're adding the same number as you go from shape to shape. And so let's see that is the key. So here you're adding 8, and you're adding 8 again. So that's a plus 8 that's happening there. So because you keep adding 8 in this column, means that the formula is going to have an 8n. It's going to start with an 8n. 8n. And then there's a plus or minus something, including 0. It can be that you're adding or subtracting a value. But in this case, the first figure up here is 8 when the n equals 1. And so this would also, the 8n would also give you the 8. And so basically then that's just a formula, 8n. So I'm writing more in the middle. It's just a formula for this column. 8 times the number. And you can see it. This times 8 is 16. This times 8 is 24. This times 8 is 8. So you see that the formula is 8n, n times 8. Then this one now, to go from this to this is a plus 6. And then to go from 14 to 20 is another plus 6. So since that plus 6, it means that 6n starts the formula. 6n must be a part of the formula. 6n. But the first figure up here is 8. So remember, in the first figure, the n is equal to 1. So they put the 1 on this, you would have 6. To get the 8, you're going to have to add 2. So the formula becomes 6n. I have to add the 2. The formula becomes 6n plus 2. Now what you can do just to make sure is test it on the other lines, or 2 other lines. For example, when the n is 2 right here, put it down here, 6, 2 is 12, and 2 makes 40, which is good. And here when the n is 3, put on the formula there, 6 is 18, 18 plus 2 is 20. So it means that the formula is correct. And then we can populate for this row. Now, this one kind of easy because it is a fourth shape. It is the next shape. So we can continue this pattern by adding 8. And 8 times 4 will be 32. Or as I say, you could take the 4 and put on the formula here. So you'll see 32. All right. And then now, here, we take in the 4 again. Or we can add the 6 to this. And this going up by 6. So we can add 6 to this one. Sure. Press the wrong thing, guys. Press the wrong thing. Right. So I can add the 6 to this one as the next figure. I get 26. Or we can take the 4, put on the formula. 4 times 6 is 24. 24 plus 2 is 26. So anyway you want to look at it, this is 26. All right. Then for this line now, what it is that we know this value. And we would like to find the value for here, the n. So the easy way to do that is to equate this formula to this to see what the n is on that line. All right. And so we can see what the n is there. So we're going to put, for this row, we're going to find the n on that row. We're going to put the 6n plus 2 formula equals 86. Subtract the 2, we're going to get 6n equals 84. And we're going to divide by 6. So divide this by 6, we're going to get 1. 1 divided, we mean a 2. I think it's 14, that. All right. That's 14. Hold on, somebody called me. Hold on a second. Hold on, I'm going to send a message down to class. Hold on a second, guys, please. All right, so it means that the value for n over here is 40. So we're going to put it over here. And to find the value for this cell, we'll take the 14 and we'll drop it on this formula there. So get 8 times 14 or 14 times 8, 8 times 14. So you take the formula, drop it over here, you're going to get 8 times 14. So that figure is 112. So right here is 112. Didn't have to write this one, we'll just put 112 there. And maybe show the working over here, or we get it. And that is it, the table is done. Simple as that. But good? But okay? Hello?
Yes, sir.
All right. Then we'll come to the next part of this question. It says, for any figure n greater than 1, the number of dots d is greater than the perimeter. And you can see it up here for real, right? So when n is equal to 1, they are equal. The dots and the perimeter equal. But when it comes to the other figures, the dots more than the perimeter. All right? That's more than the perimeter. So what I want us to do, it says determine the value of n. All right. But can you hear me now again? Can you see the screen?
Yes, sir.
Yes, sir.
All right. So let's have a look at blip in the internet. Go on again. Oh man. 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 Let's see what's happening here. Okay. What is it? Still see the screen and hear me. Let's have a look at blip a while ago again. Then I kind of unstable. Don't check in again. Can you hear me? Can you see the screen?
Yes, sir.
All right. All right. So this was that plus 2. Right here. All right. So what we got, as I was saying, they tell us that there's always a difference, and I want to know what value of n will make the difference be 36. So the d minus the p must be equal to 36. Equal to 36. But this is the formula for the d. I'm gonna write 8n right there. Minus bracket p. I'm gonna put it in bracket. The p is equal to this. 6n plus 2. I have to be careful with this negative sign. 6n plus 2. That must be 36. So 8n minus 6n is 2n. Minus this 2. That is equal to 36. Take over the 2 and add it and divide by this 2. You get up here n equals 38 over 2. N equals 90. That's the answer right there. All right, and that finishes that question. Everybody good with that? But okay?
Yes, sir.
Let's move to number 8, which is quadratics. They give us a table. Remember the quadratics, you can look for the symmetry of the quadratics function in the values on the table, especially on the y values, when your x values have equal interval, meaning they're increasing by 1 from point to point. You see, these are all increasing by 1. And so these y values are gonna be symmetrical about some line of symmetry that we can actually mark in the graph. And based on these two middle values being 9, I know that the line of symmetry is somewhere right in between here. So basically the average of these two x values is where the midpoint is, where the vertex is. All right, I'm gonna have to find a y value at the vertex. So the x value here is just the average of these two, which clearly is 2.5. So it means that the x value at the turning point, where the vertex is at the turning point, you know, the x value at the turning point, xt, is gonna be average of 2 and 3 is clearly 2.5. Then to find the y value, which will be the y value here. Let's have it done again. Oh boy, today is unstable. Today is unstable, guys. Unstable. Number 3 is up. All right. Down again. Unstable to the bottom. Don't know what's happening. I don't know what's happening. All I know is very unstable today. I start sharing screen again. It's unstable to the guys. I don't know why. All right, check again. Can see the screen? Can hear me? Just checking. Let's make sure.
Yes, sir.
All right. Cool. So this is the x value at the turning point. See from the symmetry of these values, right? So right between the 2 and the 3. Half between 2 and the 3 is 2.5. And then the y value at this where x equals 2.5 is the xt value. You can get that by substituting this 2.5 in this function. Right? So here, yt value would be y value at the turning point, they put it in this formula and that function. It will be 3 plus 5 times 2.5 and then minus 2.5 squared, which is the small. And then subtract 2.5 squared. Right? And you can get the y over the turning point, just like that. And it's a maximum turning point. So you know it's going to be a value greater than 9. As a maximum value cannot occur at two different points. It occurs at one point, which is a vertex point. The maximum value is not 9. As 9 is at 2 points. The maximum value must be at only 1 point. I'm going to calculate this out, my calculator. Right? And it is 3 plus 5 times 2.5 times 2.5 squared. That times plus and 5. Let's go again. 3 plus 5 times 2.5 plus. It's in the wrong formula, guys. All right. Something is wrong. Oh, it's a minus. Okay. I'm doing it on my calculator and they put in the wrong thing. So it's 10.25 I'm getting. Let me do it on the calculator on the screen for everybody to see. Do it on the screen. I'm working out the YT value. And I know the XT value is 2.5. And the XT value is 2.5 because it has to be symmetrical. All right. So it's going to be 3 plus 5 times 2.5 minus 2.5 squared is 9.25. See, you get the wrong answer a while ago. So 9.25. See, a little bit more than the 9. All right, so it means then that the vertex, all right, means that the vertex is going to be a maximum turning point. So the maximum point, right away at the maximum point, before we start doing anything. Maximum point. This is X value, this is Y value. 2.5, 9.25. That's this. 9.25. That's the maximum point, right? And then now, as I said, because of the symmetric nature of the value, we can start populate these cells that were left out. All right, so let's work. So if I work out this one first, that will beside the 9. Whatever this value goes to 9 this way, but this value goes from to 9 this way, this 9 will go to the same value. So these two cells are gonna have the same value. All right, so these two cells have the same value. These two cells will have the same value. These two cells have the same value. Okay, let's see over to the again. Okay. Right, these two cells have the same value. So I can know that this is 3 already now. And these two cells have the same value. So this is -3. Just by the symmetric nature of the values around this axis of symmetry, this becomes the axis of symmetry. So these two values these two cells have the same value, same Y value. These two have the same Y value. These two have the same Y value. It's 3. These two have the same Y value. So the only value I need to really work out is this one. Then I'm putting the same value inside here. I'm putting x equals 1. X equals 1. Put the 1 inside this function. The f of 1 is 3 plus 5 times 1 minus 1 squared. That becomes 8 minus 1. 8 minus 1 is 7. It means that right here is 7. And because of the symmetric nature, right here is also 7. Those are the values in the table. But go to that. But okay with that?
Yes, sir.
Right. If you want it, you could plug in the 0. And so that 0 clearly is going to give you 3 for the Y value, right? 3. All right. If you want to get this one, you can plug in the 4 and get the same answer. And for this one over here, plug in the 6, the function, you're going to get this, going to get the same answer, right? So you can try those if you want. But I like to use the fact that the graph function is symmetrical. All you have to do is pick up the symmetry of the values and you go and clear. The values are symmetrical outwards from the axis of symmetry. Or you can put another way and say they're symmetrical inwards, towards the axis of symmetry. The values are the same. All right, so that is it. All right, so those are your values. Then naturally, they want us to draw the graph. What it is that they have left off the points that were not given. So they have left off 0, 3. So on the y-axis right here, this is 2, 4. So right here says 3. There's a point right here. They have left off 1, 7. 1, 7 is 1, 7 is right here. And they've also left off this one over here, which is 4, 7 and 6, -3. 4, 7. That's 4 up to 7. To the 7. This intersection. And then the last one is where is it? Is 6, -3. So it's 6, -3 down here. 6, -3 down here. And then after do is draw the smooth curve through those points. I'm just going to draw it in red. Oh, by the way, we need to put in a vertex point, right? 2.5, 2.5, 9.25. Let's see if we can put that in. So we're right on this line. That's a 2.5 line. X equals 2.5. And we need to put a maximum point of 9.25 on this. All right, let's look at it. So this is 9 right here. Then we got 9.5 is right in the middle there. So the 9.25 is about here. So come across on a graph and meet with this line. So I'm just gonna circle these purple. All right. So we're gonna put that maximum point. Let me leave this. Let me leave those. I'm gonna go up to that maximum point up here. The vertex up here. That's smooth curve. So come again. That's it. And then on the other side, you notice I make it come all the way up to here. And then you go back through here. Guys, if I sound a little bit tired, just bear with me, okay? I'm just a little bit tired from traveling today. I just want to get through this so we can get back to the business at hand. But that is the graph, guys. That is the graph. Very important that you're putting this point up here. As note, it was not given in the table. This point up here is the maximum point. It's a maximum point, and it is 2.5, 9.25. It's very important that you're putting that point. Then it says, write down the equation of axis of symmetry. See? You can look at it and see it. This same line here. This is axis of symmetry. We're going to draw it in blue. The vertical line passing through that terminal point. Put the x-axis at 2.5. The axis of symmetry is x equals 2.5. We're going to say that. X equals 2.5. Then now state the maximum value of the function. Maximum value is the highest y value, yt, which is 9.25. Yt value is the maximum value. That's it. Yt value is the maximum value. All right. This says now, write down the coordinates of the point where this line crosses the x-axis. Now on the x-axis, you know that y equals 0. So this can I put in this equals 0. Right? And we put in this thing equals 0. So we're going to say i.e. 3 minus half x equals 0. So this and that you're trying to find the x. X must equal 6 because half of 6 is 3. 3 minus 3 is 0. The answer is half x. Where it crosses the y-axis. Now on the y-axis, x equals 0. If x equals 0, plug it here, so you're going to have the y equals 3. Actually, the y-axis is in the same. So y is going to be equal to 3. And the question asking for coordinates, so we're not done. So we have to actually write the coordinates as answers. I put the answer in purple down here. So it is 6, 0. This one, the y value came out to be 3. So this is y equals 3. I'll shift this over. The point is going to be 0, 3. That is that. But okay with that so far?
Yes, sir.
Then they say now on the grid we must draw the line. But remember now the line where we have 2 points that pass through. We have 6, 0, and we have 0, 3 that we can use, right? 6, 0, and 0, 3. So we can use them on the graph. So you pass through 6, 0, which is all the way out here. Should I use a different color? I'm use color can I use for that. I don't use red. So 0, 0, 6, 0 is out here. This point out here, 6, 0. And then 0, 3 on the y-axis here. So I need a straight line to do that. Right? 6, 0, 0, 3. 0, 3, 6, 0. But I can also use a gradient at the half, which is minus a half. So the gradient is minus a half in this line is minus 1 rise and 2 run. All right, so I can go up to the graph and just use that to draw the rest of the graph. So starting at this point, minus 1 over 2 in rise minus 1 on 2. All right, so remember that the horizontal axis is scale is different from the vertical axis. I'm talking about units. So from this point, you can use the gradient to find other points. Rise negative 1, run 2. So 1, 2, they come into here. You rise negative 1 and run 2, 1, 2 there. And rise negative 1, run 2 there. All right, so those are the points. And we just need to join them with a straight line. Something wrong, you know? Something is wrong. Rise negative 1, run 2. Then you say have the y-axis intercept is 0, 3. Where is it? 0, 3. Yeah, let me see. 0, 3 is actually right here. All right, so these points are wrong. Do them over. Come again. Starting right here, 0, 3. Rise negative 1 means come down 1, run 2, 1, 2 to here. And rise 1, run 3, 1, 2, 3 to here. Something still wrong, you know? Run 2, Mr. Shaw, run 2, rise 1, rise negative 1, run 2, 1, 2 to here. Rise negative 1, run 2, 1, 2, okay, good. But as I said, we could just use these 2 points and do it. I'm still kind of trying to practice. We can use the gradient to draw the graph. Erase the part of the curve. You can draw it back here. It was coming all the way down to here. Let's draw this line in red. So we're gonna be drawing through these points, right? Let's draw a straight line through those points. That you have to draw it with the ruler. You won't draw it free on the line. Me, use the ruler and draw it. That is the line. You can label it. Y equals 3 minus half. And natural axis for the way they intersect. See? So draw the graph, and like I said, using your graph, determine the solution for these and that. We discover where they intersect, according to the intersect from the graph. So we can look at the graph and just write them down. They intersect at this point, which is 0, 3. That's also intersect at this point. I don't know. That looks like 5.50. And we can graph paper and temper again. 5.50. It intersect right here. I want to say the intersect right here. All right, so it is 0, 3 and 5.50. This is it. That's where the intersect at those 2 points. The standard. Very good. All right.
Yes, sir.
All right. 2 more questions. I'm really very tired now, guys. I'm just trying to get through this. So we can focus on the mock exam for Saturday. All right. Sunday and Monday. We're actually doing 2 mock exams. All right. So when you come, you'll see what it is. All right. This question said diagram below shows a circle with points P, Q, R, and S line on circumference. It says, and its center marked O. All right. So center is O. That's a diameter. That's a diameter subtend 90 degrees at the circumference. All right. Well, let's continue. It tells us that angle APQ is 3x degrees. APQ, right? Is 3x degrees. That's the angle between the tangent and the chord. So the chord is going to subtend the same 3x over here. So I know right away that these two angles are the same. 3x equals 54 degrees. But let's continue. And it says QPR is 2x right here. Then RPS is x right here. And then QSP is 54 right there. Question said, determine the value of each of the following angles and show detailed working where necessary and give a reason for your answer. The first thing I want is x. I just said, I want x. All right, I want x. I'm going to work x by 2 ways. You can say x, you can say that between here and here, 90 degrees. So these two angles are up to 90 degrees. Maybe that's the easiest way, actually. So 5x equals 90 degrees. That's one way, right? And that will be tangent and radius 90 degrees. So 2x plus 3x, 9. Let's write it out. I'm going to say, I'm going to use that and say 2x plus 3x equals 90 degrees. So 5x equals 90 degrees. 90 divided by 5 is how much? If you divide 90 by 10, you're going to get 9, and divide by 2, you're going to get 4.5. Right? No, you're going to get twice as much. 90 divided by 5, yeah. Twice as much. Yeah, so you're going to get 80. So the x equals 80. As I said, we could have put the 54 equals 3x and divide by the 3 and get the same 80. Like those consistency. So based on that, and we did we put just x, right? So x is just a number, guys. The question said x degrees. X is just a number, don't put in a degree on it. It's just a value that we're trying to find. In this case, it is 80. And this is because angle between tangent and radius is 90 degrees. That's what we use. All right. So the x is 18. Now, what does I want us to find? I want us to find y. Let's got the diagram y. I want to find this y over here. Now, these two angles must add up to 19. Why? Why is that? Because this is a diameter. Diameter subtends 90. So this is the right angle triangle right now. This. And the angle over here is 90 degrees. So these two must add up to 90. All right? That's the premise on which you're going to do it. X plus y equals 90. Complementary angles. X plus y equals 90. Y equals 90 minus x. My x is 18. You know? y equals 90 minus 80. Y equals, and then we're going to put it there. Complementary angles in the right angle triangle, but angles obtained by diameter is 90 degrees. But understand that calculation? But understand that?
Yes, sir.
All right, something 72 degrees. The reason for this is that this angle is 90 over here. These two, I'm going to tell them that this is a right angle triangle, but the angle, that semicircle is a right angle triangle. So I'm going to say triangle RSP. Triangle RSP is right angled. Since angle subtended by a diameter is 90 degrees. All right. That. Which other one? I want Z next. All right. For angle subtended by a diameter 90 degrees. And so it's a right angle triangle. It's a right angle because angle subtended by a diameter 90 degrees. So these two angles must have 90. Cool. All right. So the one Z next. So Z next up here. But these two angles are the same now. Just an easy. Why? Both of them subtended by this chord. This chord subtending this angle up here using these two subtending lines. Same chord subtending these two angles up here using the same lines. So the answer is going to be that these two equal. So Z equal Y. Same segment rule. So Z equals Y, which is 72 degrees. Same segment rule. Angles in the same segment are equal. That is it. Anything else? Better go to that up there. But okay. This one pretty straightforward. Better go to this.
Yes, sir.
Yes, sir.
Nice. So this one now is this bearings question. Once into that, we might also have some sine rule and cosine rule in it to do. Right? Non-right angle triangle use sine rule and cosine rule. They say the diagram below shows straight roads connecting two towns. Connecting towns L, M, N, and R. It says LR is 18 right here. LN is 12 right here. And MN is 10. I didn't show MN. Yes, MN is 10 right there. It says angle RLN is 25 degrees inside here. And angle, where is it? And angle LMN is 88 degrees right here. All right, it says calculate angle MLN. MLN. We're trying to find this angle right here. So to find that angle, we're gonna come and work in this triangle that I'm marking out in blue. That triangle is not a right angle triangle, so we cannot use Pythagoras theorem. We cannot use so-called or use sine rule and cosine rule. Now remember, this is the angle that we want to know. And to this, always look to see if you can use the sine rule first. To use the sine rule, you need an angle and a side in the triangle opposite each other. We know that you know the values, you know them. So these two are there. So if you use those two which are there, so it means that we're going to be the sine rule because we have a known angle and a known opposite side, and then we're going to work that to those two. All right, we're trying to find the angle here, alpha. So let me do it here and then copy it down. BTM and copy it up. I'm gonna say sine rule for the alpha. Sine rule. For alpha. Sine of alpha over the opposite to alpha is a 10 equals sine of the angle that you know, which is 88 over the side opposite to 80, which is 12. All right, that's the sine rule. And I want to find the alpha by taking the 10 and multiply it up here first, and then take the inverse sine. Let me go step by step. So the sine of alpha firstly will be 10 times the sine of 88 degrees divided by 12. You take this sine and put the inverse on that. Alpha equals sine to the minus 1 of 10 sine 88 divided by 12. All right, that's what we're doing. And then we record the alpha that way. Let me get a calculator. I want to sleep, guys. I'm tired. I haven't slept since last night, you know. I've not slept. I sine to the minus 1 of a fraction at 10 sine 88 over 12. That's 56.4 degrees. All right, so that's 56.4 degrees. I just need to just copy this down. Actually, just move it down here. Move it down this. All right. Move it up some more. I'll move a part of it over here. Yeah. It's over here. All right. Good. From here, we go to there. Okay. But good so far?
Yes, sir.
Yes, sir.
Remember, you find something, you put it on the diagram. Don't joke. This angle is 56.4 degrees right here. Now I want us to find the length of, what is it, an hour here. So to do that, we're going to come and work in this triangle. And now, because we have two sides with an angle between them, we're going to use a cosine rule. I'll put another way. The one angle that we have, we don't know the angle from it, we don't know it. Therefore, we cannot use the sine rule. We're going to use the sine rule in this triangle. I'm going to do it, not the sine rule, the cosine rule, sorry. We're going to use it right here. Cosine rule. Let's tell example. Cosine rule or NR. My stars are like 5 seconds here, right? So remember that NR squared and going NR squared equals this side squared plus this side squared, working in this triangle. So it's 12 squared plus 18 squared minus 2 as a product of a 2 minus 2 times 12 times 18 times cosine of the angle between them. Angle between them is 25 degrees. And then if I put in a square here, we can actually take it off, put a square over this. With the mic, please. With the mic. With the mic, please. I must work with NR one time.
So I'm saying me nothing.
Mute your mic, please. Mute your mic, please. Oh my goodness. They're playing music. All right. All right. I'm going to work this out now. Square root of 12 squared plus 18 squared minus 2 times 12 times 18 times cosine of 25 degrees. That is 8.75. Right? They tell us, oh, accurate, I wanted more. I'm going to write 8.75. 8.75 kilometers. All right, let's copy this down and cut it down, paste it in its rightful place. But in R right here. But good? But okay? Hello?
Yes, sir.
Yes, sir.
Next, I want the bearing. Calculate the bearing of on R. I want R from L here, from L to R. The bearing must be measured at from position L. I always look out for that, guys. The bearing must be measured from position. I'm going to show the bearing angle that I want at the diagram, or like theta. And then you go about calculating it, right? What you want to do is show the angle that I want on the diagram. Right, so I want the bearing from L to R. Let's look at it from L to R. All right, so that's from this point down to this point, you want the bearing. All right, so the bearing must be measured at the front position. So this, all right. So what you have to do at the front position L, I have to stand at the front position L. Face not first here. It's the angle through which I have to turn to the right all the way around here to face R. So basically, some of these three angles never saw them before. Those three angles. All right, so that is it. Some of those three angles gonna give us the bearing that we want. But I get that.
Yes.
Bearing of R. Good. All right, so we can just write it here and then move it down. Bearing of R from L is some of those three. All right, so bearing of R from L is equal to 50 degrees plus 56.4 degrees plus 25 degrees equal. Let's do it on the calculator. It's 50 plus 56.4 plus 25. That's 131. 131 degrees. I usually give bearings to 3 digits only. Don't put the 0.4 on it. Eh? So correct it to 3 digits. So let's cut this. Cut that. And paste it where it is supposed to go down here. Good, that is it. But good? But all right? We have one more question. You can call it a day. Get some rest and
Yes, sir.
come back. All guns blazing. All guns blazing. After boys and girls chant, but we'll do the first paper Saturday. 2 papers they did on Saturday. One in the classroom, one at home. Right? Because you can't come, you have to work out something for them. I want students to come so they can practice the time management, to practice how to manage the time in the exam, to maximize on the marks. Something you have to practice. So you're going into the exam room with that plan. I want to work out that, what that plan is and employ that plan. Practice how to employ that plan. Give us the best opportunity to get all the marks on the exam paper that we know how to get. And don't come out the exam room and then discover that there's a question that you did not do. That you never reach a question. No, that's not good enough. All right. This question says 3 points O, P, and R are shown in the below. O is the origin. So let me here O, P, and R. All right, question says write the position vector of R, OR. So since R right here has coordinates 5, 1, OR will have the same values in the position vector 5, 81. That's it. Want to go to that? But all right? We can write the other one too, you know. We can say and OP is -2, 4. -2, 4. That's it. Next part now says another point Q is located such that QR is 2, -4. Use information to plot the point Q. So you need to know what point Q is. Now we can do this in multiple ways. Look here. Remember that we know the point R already, right here. And we want to go to Q. So this now is the vector that will take it from Q to R. It means that the vector from R to Q, which is the opposite direction of that, all you have to do is negate these values. It's going to be -2, 4. So if you had R already and want to reach Q, all you have to do is -2 units in the y direction, 4 units in the, sorry, -2 units in the x direction, 4 units in the y direction. That's all we have to do. Starting at R. I'm also going to do my calculation method and show you. So what I do is -2, 4 to go from R to Q. Just negate these values because all I've done with these two vectors is spin them around. Inverse them. Opposite direction. Opposite direction vectors indicate with negative sign. So then -2, 4 to go from R to Q. -2, 4. See just R here. -2, 1, 2, 4. 1, 2, 3, 4. Right? So that does it. So it means that the point is right here. Which is 3, 5. The first one. But I go to that. 3, 5. -2, 4. Let's do by calculation now. Let's do by calculation. So to plot the point Q, we need to find a position vector of Q. We can use this to get it. Watch this. Look at this now. To go from O to Q, we can use R as an intermediary point. Right? We can say, okay, to go from O to Q, we can go from O to R, and then we'll go from O to R, and then we'll go from R to Q. What still is this to give us in us? So we're going to split them, turn them around. All right? So we're going to turn this around, same way. So we're going to say OQ is equal to OR. Well, OR is this 5, -1. Plus, and RQ is this one we spin it around. -2, -2, 4. Something wrong. It's giving us 3. Oh, put a negative on this. Put a negative on this OR. Why did we put a negative on it? Good thing we check it. That's not supposed to have a negative. The coordinates is 5, 1. The portion vector is 5, 1. Same way. So this is supposed to have a 5, 1. 5, 1. So this is now going to be 5 - 2 is 3. And then 1 and 4 is 5. So the portion vector of Q is 3, 5. And the point Q is 3, 5. All right? Made a mistake. Wrote the wrong thing. But that is it. And the other way to do it is to split this vector and get OQ in from it. Let me do it for you. More maths equals better maths every time. Let me do it that other way as well. All right, so it's like the question is asking for the point Q. We find a portion vector of Q. We are writing them. To do that, we can split up this vector into position vectors, especially this side. Split this side. So this now, right here, this is going to become OR minus OQ. And that's all equal to 2, -4. Then the OR, the OQ want to make the subject, so I carry it over here, so and take this and bring it over here. So we're going to get the OR minus 2, -4 is equal to OQ. And this OR is, remember, 5-1 up here. Yeah, let's put 5-1 on it. And then work this out. I'm going to get that OQ. But the same thing. It's 5 minus 2 is 3. Minus is a plus. That becomes 1 plus 4 is 5. So the the STGC match and the somebody say forget about that. Sleeping off, guys. Aha. All right. But that is it. So this is the answer. 3, 5. Okay, so if this is the portion vector of Q, that means that Q is a point 3, 5. Is a point 3, 5. That's another way to do it. So I showed the 3 ways to do it. One, we use a diagram and let's go from R to Q using the vector by counting the units. 2 back and 3 up and 4 up, sorry. Or we could calculate it this way, using this way, I could split the vector here. This is a method where split the vector. Split it. The same multiple ways to do the question. Now, once you get the portion vector, it means that you have a coordinate and you can put it on the graph. That's it. I want us to plot the point Q on the graph, and it is right here. Point Q there, Q. All right, that's what they want us to do. It says now determine the magnitude of the vector QR. Magnitude is the length. All right, so this is QR. All right, look at the diagram. QR is this vector right here. Now find how long it is. You're basically using these two components and express this way and then that way. So the 2 coming this way and the -4 stands for. We're trying to find the distance. So it's Pythagoras' theorem. So when you want to look at it, remember that the QR is 2 -4. So the modulus of QR becomes this becomes the square root 2 squared, that's from this, and 4 squared. Only negative, that's the length you find it. But this is 16 and this is 4, make 20. Square root of 20 units. All right, it's now show by calculation that this thing is a parallelogram. OPQR is a parallelogram. So it's a parallelogram, OPQR. Let's look at the diagram. Take these out. All right, let me take these out. Show it in red. Because to show the parallelogram, OPQR. That's a parallelogram. Right? So how do you show that it's a parallel? You have to show that the opposite sides are equal vectors, guys. As simple as that. So you want to show that, for example, which are just picking which two sides. This side and this side are equal vectors. And that this side and this side are equal vectors. All right, so right now what we need to show here. So now OP and RQ equal. OP R. So we need to show need to show that OP is equal to RQ, which is a parallelogram. OP I put the other way around. RQ is equal to OP, and these two are going to show that those two parallel. And you have these two now. So PQ is equal to OR. So we show us that PQ is equal to OR. To show that the thing is a parallelogram. That's what we need to show. So we copy this down. Copy this down. All right, that's the approach that we use to show the vectors are parallel, but the same vector. All right, so we're doing this. All right, so we know OP already. We know OP already. Now. OP from the top was OP was bam, 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 bam. OP would have from the ground. I'm gonna write it on it. Negative 2, 4. Okay, so negative 2, 4. OP will be negative 2, 4. And 2 parts to show that print color. Negative 2, 4. And then OR, remember OR from the beginning was 5, 1. 5, 1. 5, 1. Need to find RQ. So now RQ is equal to OQ minus OR. O times the last minus O times the first. So the OQ minus OR, OQ minus OR. So I did OQ minus OR. All right, so the OQ now is what? OQ, we just worked out a while ago. It's 3, 5. This is 3, 5 minus OR. OR now is OR is OR is this 5, 1. Right? OR is a 5, 1 that we have. Where is it? OR was given as 5, 1 right here. 5, 1, 1, 5, 1. So subtract negative 3 minus 5 is negative 2. And then 5 minus 1 is 4. And that is what is shown so far, right? That's the first part. The next part we need to show now is this part. We find PQ and show say equal to R, OR, which is 5, 1. All right, so the first part of it already, we're going to say, and the EQ is equal to OQ minus OP, which is, but the OQ is the same 3, 5. Minus the OP is, where are you? OP is negative 2, 4. Negative 2, 4. You work this out, this minus a plus again 5, then 5 minus 4 is 1. To show that is possible, it's shown, see? Prove this enough, I've shown it. So say therefore shown. And that is. But I got it that. But okay?
Yes, sir.
Remember, I need to go and write the questions over again. And what I didn't do, you didn't misunderstood, didn't understand. You need to go and write them over again. Alright? Now we'll come down to this line now, which is now matrices. Alright? Finishing off. Really very tired, guys. Struggling through this thing. But I'll be fresh again, so don't worry. It says calculate the value of x and y in the matrices equation, the matrix equation. So this is what we call an equality of matrices. What it is that the product of these two is equal to this one. Remember that when you multiply matrices, you multiply the rows of the first matrix with the columns of the second matrix. What do we know? We know that, for example, this x is obtained by multiplying this row and this column. So we can write that. That's okay. The x that we're trying to find is actually equal to this row, 1, 5, times rows by column, right? This x. So multiply that by negative 4, 2, negative 4, 2. And then we can work that out, right? Then now, how do we get the y? The y is part of an equation. So it is in the second row right here. So the second row and the first column actually give us that 6. We can set up an equation like that as well. Let's do it over here. So we can say 2y times minus 4, 2. That is actually equal to 6. All right. So let's work out this one first. It becomes 1 times negative 4 and 5 times 2. 1 times negative 4, negative 4. 5 times 2 is 10. That works out to be 6, and the rest is this. And then this one now, we want to find the y. What do we know? We know that this times this plus y times 2 equals 6. So we're good to go. It's going to be the y times negative 4, negative 8. 2 times 2 is 12. Sorry, 2 times 2 is 4 in the sleep. All right? What am I doing? Jesus. All right, yeah. This times this, first element times first element, second element times second element equals 6. All right, let's go again. 2 times negative 4 is negative 8. And then y times 2 is 2y. And that's all equal to this 6. I'm trying to find the y, so we can divide 2 by 2 first. Divide 2 by 2, simplify it. It's become negative 4. It becomes y. And it becomes 3. This negative 4 goes over there, add to 3. And so the y is equal to 7. All right. Very good. Know that I'm sleeping. Know that I'm sleeping. Get it through.
Yes, sir.
All right. Get it through. I'm getting through. Know that I'm sleeping. Going on. Let me gently. Let's go. Let's finish this thing. Part C said, the last question. Part C said, transformation T is represented by this matrix. I must know that this is the y equals x reflection matrix. What it does, it reverses the coordinates. You see, 2, 4, 2, 5, sorry. The coordinates are reversed to 5, 2. And that's what that matrix will always do. Reflection line y equals x. It says, describe fully distinguished transform. A reflection line y equals x. Wow. Easy question. A reflection, then not writing good. A reflection in the line y equals x. And that is that. That's for today. I got you guys. Very, very tired. I got you. All right. So clear this now. You know, Saturday morning, 8:45. We're doing our mock exam. You're doing 2 papers. I'm gonna do 1 in the classroom. I'm gonna get 1 to go home and do. All right. So one of them will be worked out on Sunday. Other one will be worked out on Monday. And so that they can grade yourselves. I have a target of 30%, just 30%, because this is the first one we're doing. We will eventually work towards getting 90%. But right now, 30% is good. We're just starting our exam prepping full. All right, that's a pass mark. That's the mark that we don't want anybody to fall below. And then we're going to work on improving as weeks go by. We'll get to the exam. The 2 papers are doing, 1 in a classroom, 1 at home. Make sure them. I'm going to go through 1 of them on Sunday. I'm going to go to the second one on Monday. And I want to break for a week of champs. I want to start back class following Sunday, the day after
Excuse me,
champs.
sir.
Yes?
Is it online or face to face?
What? The Saturday mock exam?
Yes, sir.
Face to face, man.
At
Yeah, on the
8:45.
exam. Huh?
At 8:45.
8:45 a.m. Yes, because your real exam start at 9. So actually, you actually starting the paper at 9, but you can't come here at 9 just to start the exam at 9. You start working at 9 a.m. in the real exam on May 9th and also in the real exam on June 6th. You will actually start doing the paper at 9 a.m. in the morning. So we are practicing for that condition. We're practicing for that. So we're simulating those exam conditions fully, as closely as we can. So even the time, we are mirroring the time that the exam, that you have to sit the exam. If you were doing the exam at 1 p.m., I would let the mock exam start at 1 p.m. All right? We are simulating, we are practicing to see to get as close as possible to the conditions that you will see on exam day, that you will encounter. So when you actually get there on exam day and you encounter those conditions, you are in a familiar place. You don't feel strange still. All right? You must just know that you go in there, just work some questions and just get them right. You understand me? There's no time to be thinking about anything else. So we have to practice those things, and you also need to learn how to manage the time. Yes, that's why I said 8:45, because starting the paper, you will come at 8:45, be seated, sit down, and start working the paper at 9 a.m. Right? 9 a.m. So not accepting birth occur in the real exam now. If you reach the exam room half an hour later, you can't do it. And it's the same thing here now. Or practicing for exam. So I can't let anybody get comfortable with coming to the mock exam late. That means that you will be able to go to the real exam late as well. And that is unacceptable. Some persons have special situations that they ask for, for us to do a couple of things that are a bit different. That's fine. But in the main, you need to be here at 8:45, seated, put the bags one side, right? And get ready to do a paper on the exam condition for the full 2 hours and 40 minutes straight. But that's what you're practicing to do on the exam. All right, it's not a joke thing, it's not an important movie thing. A serious thing, that's a significant part of our preparation. It might be the most important part of our preparation. Practicing to do the exam and do it the right way and managing the time. How you manage the time? How do you maneuver the time? How do you get yourself familiar with the structure of the paper and the order of the question? You must do a question and turn and know what question is coming up next. Like your brain condition. You know, so okay, the next question is a statistics, for example. And next question after this is going to be my pattern question. And the next question, you must know what the question is going to be. So when you see it, you know that you're in a comfortable place. You have familiarity to the hilt. All right, so I want you guys just get serious now. That a week, a little break, a chance, fine. And I'm actually going to be sending work during that week anyway. So you're going to be given some assignments to do the Sunday and the Monday after we come back from champs, after break. After we break for champs, after we come back from champs. Right? You're going to get a paper to do in that June champs. Do them on your own time. And so we'll come back the Monday, Sunday and the Monday. Those are the papers that we are going through in the class. All right, I send the target views to the group, and I also send the bank of exam papers that we're going to be doing our mock exams from. I'm going to pick in those papers using a strategic method that we practice. All right, so nothing is arbitrary, guys. Everything is a plan. Everything we do have a specific reason. There's a reason for everything. I tell you why it's 9 a.m. Just tell you a while ago. But the real exam is 9 a.m. I tell you why you can't reach your 9 a.m. for exam that is starting 9 a.m. You have to reach before, get seated, get your paper, and so on. Sit down comfortable, put the bag one side and all of that. You have to do all those things. Same thing you do on exam day. You have to call the register and all those things. All right. So that's what we're doing. So see you guys on Saturday. I would advise you to look back through some of the papers that we have done, all the videos for all the work that we have done are in the group. You can just basically do a search for the links and you'll see all the papers that we have gone through and everything. But even though the pass mark that we're setting is 30%, you want to get more than that, you want to try to get as high as possible in it. But I am just okay with 30% now, because we're just starting out. I am okay with 30%, but you know, the whole idea is that you will learn from your mistakes. And our primary objective, I can tell you from our primary objective in doing the mock exam, right, is to, among other little things that I mentioned, is to learn from the mistakes and don't repeat them. So you do a bearings questionnaire, I have to do a certain thing, I make a mistake on the first paper that we do, and then I go through it, and you see the right way it should be done, and do another paper after that, and you see a bearings question asking for a similar thing to do. You don't go making the same mistake again. You eliminate the mistakes. Eliminate the mistakes. You don't repeat the mistakes. And that is what I'm going to do the assessment on later down to see who are the persons not taking time to focus on the mistakes to ensure that you don't make the mistakes again, you don't repeat the mistakes. Anything you get wrong, you must get it right the next time. If you get any question like it. Right? That is it. All right, guys, I'm gonna end the class now. Mr. Mario calling me now. I'm gonna end the class and I'm gonna take it from there. Okay, guys? I'll see
Bye,
you
sir.
all. See you all. See you all on Saturday. All right, bye everybody.
Bye, sir.
Bye. Okay, bye bye. All right, I'm gonna end it now.